Okay, so did you guys all look at the website? You saw what's on there? Notes for meet one. So I made notes for each event, like, and did you get a note from Mr. Monaco?
For what?
Okay, never mind. Here. Maybe you're too young, that's why.
Eh?
For the IM squared thing,
Oh, yeah.
I guess they only do 11th and 12th grade. Okay, and then did you guys look at the calendar? So I'm just gonna make sure everybody understands what's going on. Okay, so the calendar looks like this. This is the meet. Yeah, this is September 15 at Moana Loa High School. Okay, so we're gonna get a bus. Okay, so you don't need to go there on your own. The school will get a bus. We leave school at we need to be there at 8 o'clock. So we'll probably leave school around 8:40, 7:40. So usually what we do is, are you going to the IM squared? Did you get a note? You didn't get a note? Okay, yeah.
Oh, I have to leave early because of a lunch show.
Okay, that's fine, because we're gonna videotape this.
What?
So much for mandatory. Now I forgot what I'm talking about. Okay, so we have a holiday. This is a holiday, right? Next week. Now, did you guys look event 2? Mr. Masunaga, right? He's over here. He's in G201. Now, normally you have to hand in your worksheets the day before by 3 p.m. But that would be tomorrow. But that's kind of not enough. So I'm assuming this is okay. You're allowed to hand in your worksheets by 7:30 that morning to Mr. Masunaga, G201. Okay? Are you in event? Yep, you're in event 2. So if you're in event 2, you can hand in your worksheets to Mr. Masunaga, G201 by 7:30. If he's not there, put it under the door. Okay? Worksheets cannot be late. Because this year there's going to be I'm just going to replace you. I'm just going to grab somebody else. Things happen. Okay? And same thing for us. So when is event 3? Nobody memorized the calendar. Event 3. Okay. So you hand in your worksheets to who's the coach? What is event 3? Evaluation. Is that Mr. Takeuchi? You hand in your worksheets to Mr. Takeuchi the day before. I believe his room is W213, I think, but it's on the calendar.
It's Gillian.
Mr. Gilliu?
Yeah.
What? Mr. Gilliu's doing evaluation.
Yeah.
No. Oh, Mr. Takeuchi's doing sets then.
Yeah.
And when is that? Friday.
Yeah.
Yeah, no.
Okay, whatever it says on the calendar, the day before by 3 p.m. Okay? Now this year, see, because what happened in the past, especially the newcomers, they have like, oh, I didn't know how to do the problem, that's why. Because incomplete worksheets when you hand in, not acceptable. You need to, and that's why we're doing all these other things so that you're able to do the worksheets, okay? So, like event 3 is pretty easy, you just gotta compute numbers, yeah?
Event 5 is Wednesday.
Okay, wherever it is, it doesn't matter where it is, okay? Just make sure you get it in the day before. So we're doing things to help you so that you can do a better job on the worksheets, okay? So, first thing, we're gonna go over the tryout so you have an idea of what you need to do. Also, I made notes for you guys, which is on the website, yeah? And if for any reason you still cannot do some of the problems, come see me. Just come see me, I'll tell you how to do it really fast. Okay, and if you absolutely cannot do a problem, you just befuddled, then just put a question mark there. At least show effort, okay? If there's just a blank problem with nothing there, then you're gonna be in trouble. Okay? So all we ask for is an honest effort. Now, did you guys click on the OML website? I think one of the links on the site said OML website, Oahu Math League website. Well, if you go over there, remember I told you to look over there, you know, for practice problems and things? There's the last 20 years of problems and all the answers are there. Like if you scroll down to the very last page, that's all the answers. So you have access to the answers. Okay? So what does that mean? Oh, can I just put fake work and then put the correct answer? No, you'll get even in more trouble if you do that. Okay? Now, if you're stuck on a problem, you just use it to help you learn. Now, that's the main thing is you want to learn here. So, it's okay to, like if you're doing a problem and you look up the answer to see if you're correct, that's good. And if you cannot do a problem, it's okay to look at the answer and try to work toward the answer. But it is not okay to, oh, the answer is 5, I don't know what I'm doing, I'm just going to write 5. No, that's bad. Okay? So there will, and so I told the coaches already, if you see any cases where the correct answer appears out of thin air, then they're going to tell me, and then I'm going to come see you, and then it's not going to be pleasant. Okay? So if you don't know how to do a problem, like if you want to, you can write the correct answer here, like, you know, just so that you're working toward it. If you don't know how to do a problem, just do this, and then the coach, when you go to the workshop, then the coach will help you with that. Okay? So hopefully this will go more efficiently. So, did you guys even look at the website that has the answers in it? Okay, so that means when you go to the workshop, because before in the past, they just used to do the corrections there, but now, I would guess since you guys have the answers, pretty much everybody's gonna have it all, almost all correct already. So they can spend more time going over shortcuts and doing neat problems with that event. Okay, so the first thing I want to, so the older guys aren't here anyway. I'll do that after. Okay, let's start with the easiest problem, easiest event. Evaluation. This is the easiest event for the whole year. All you have to do is compute numbers. And like I told you at the meeting, you have to know your decimals and fractions. You guys know them yet? If you looked at the notes, did you look at the notes for meet 1? It's all in there, yeah? So when you see things like this, 0.875, you know immediately it's 7/8. Okay, so just study it. Or what is 0.4 repeating? 49. What is 0.23 repeating? 23/99. What is 0.235 repeating? 235/999. I see a pattern. What about this? 0.142857 repeating? 17. What 0.09 repeating? 111. Right? So you should know all your fractions. That's because, you know, in math league, there's no calculator. Everything is done by hand. So when you compute numbers, it's easier to work with fractions than decimals. Don't work with decimals. So if you see a decimal, change it to a fraction immediately. Okay? And the other thing about this event, sometimes instead of just plugging in the numbers, it's better to like simplify the expression first and then plug it in after. For example, what if they had, I'll just make this up. What if A is equal to 0.83 repeating, B is equal to 0.625, evaluate means compute the value of A cubed, no, A plus B, no, A cubed plus B cubed plus 3AB A plus B. Now, of course, what is 0.83 repeating? 5.6. What is 0.625? 5.8. So one way you can do the problem, I just take 5.6 here, plug it in here, cube it, plug in 5.8 there, cube it, 3 times 5.6 times 5.8, and then go 5.6 plus 5.8 and compute that. Yes, but is there a faster way? Yes. What happens if you multiply this up? You get A cubed plus, multiply this up, 3A squared B plus 3AB squared plus B cubed. Hey, you somebody. Hey, that's just A plus B quantity cubed. So all you have to do then is just add these two together, cube it, boom, and that's the answer. So lots of times, not all the time, I'm just saying lots of times it's easier to simplify it first and then plug in the numbers instead of plugging in the numbers from the very beginning. So that event is pretty easy. Okay, the next easiest event is sets. Okay, look at your tryouts. Did you get your tryouts yet, Chanel? Okay. Anyway, the one on the tryout is pretty easy, but when you have to put variables in, that's where it gets hard. So Venn diagram, super important. You gotta be able to handle Venn diagrams. Okay, so you got lunches. You got mochiko chicken, poke bowl, chicken katsu. When you do Venn diagrams, you always fill in this middle number first. So you always look for how many elements are there in the set that's the intersection of all three, and it says 18 set all three, so you put 18 there. Sometimes that's going to be a variable. That's going to be the harder problem. Like you might have to put an X there. See, and that's the reason. See, that's the difference between, like, this is an easy problem. The harder problem would be a variable there. 64 said mochiko chicken and poke bowl. So that's here. Everything in here got to add up to 64. So 18 plus what gives you 64? 18 plus what gives you 64? What do you guys have written down? Oh my goodness. Okay, 72 said mochiko chicken and chicken katsu. So this plus this is 72. So that makes this? Okay. And then 105 said chicken what? Am I missing something? Oh yeah, we don't know. Okay. 105 said chicken katsu. Where's chicken katsu? Oh, so that means, oh, we don't know what that is. So that's where you put the X. 105 says chicken katsu. So everything in this circle got to add up to 105. So this X got to be canceled out with a negative X. This plus this is 72. So how many more do I need to get to 105? 33. So 33 minus X. That's how you do that. 96 said poke bowl. So this plus this is 64. So wouldn't this be 32 minus X? Because everything got to add up to whatever it said, 96. 143 says mochiko chicken. So this is 72 plus 46. What is that? 72 plus 46. Quick. Too late. And then everything got to add up to 143. So this is 25. Now sometimes in the harder problems, like I said, this was the hard. Sometimes there's going to be some people out here too. Yes? In this particular problem, there is sometimes. So don't forget about here too. Okay, now it says, what is the largest and smallest number of people who prefer only chicken katsu? That's this right here. Now a lot of people put 0, okay, for the least, which is correct. But what is the most? A lot of people just said, oh, 33. No, because look at this. If X was 33, then wouldn't this come out negative? You cannot have a negative amount in one of the regions. So the most should be 32. So that's why you have to fill it. See, if you didn't fill this in, you would have thought just 0 and 33, but that's why you have to fill that in. You know what I'm talking about? So this is a typical Venn diagram problem for sets. And I went over the things you have to know about sets at the meeting last week, but I'm going to go over it again. Okay, what does this mean? The number of elements in set A. So for example, if this is set A, 2, 3, 4, what is the number of elements in set A? 3. There's 3 elements. 1, 2, 3. Just count them. Okay, here's set B. Set B is 3, 4, 5. Now what the heck? Let's just do 6. Okay. What is A union B? If I throw these numbers in a box and I throw those numbers in a box, what's in the box? 2, 3, 4, 5, 6. What is A intersect B? What elements are common to both? 3 and 4. And you have to use braces. Anytime you have a set, you have to have braces now. Because it's a set. Right? Now, you guys know what a subset is? Okay, look at set A. How many subsets does set A have? Like if you were to list them out, 2, 3, 4. How about 2 and 3? How about 2 and 4? How about 3 and 4? And then what about 2, 3, and 4? Are these all the subsets of set A? No, the empty set. The empty set is a subset of every set. So how many subsets are there? 8. Is there a shortcut for that? Yeah, it's on the notes. If there are n elements in the set, then the number of sets are going to be 2 to the n power. Question? Yeah, so just 2 to the n. But wait, but you gotta read, because sometimes they ask, okay, look at set A here. How many non-empty subsets does it have? Then it would be 2 to the third minus 1, right? How many non-empty proper subsets does it have? Well, first of all, what's a proper subset? A proper subset doesn't include itself. So if somebody were to ask you, what are the proper subsets of set A? It would be all of these except that one. It's everything except itself. You know what I'm talking about? So what would the answer be? What? How many non-empty proper subsets? 6, okay. And then do you guys know this notation? I think I told this to you guys at the meeting. Sometimes they write it like this. Or sometimes they write it like this. That's the complement of set A. That's everything that's not in set A. So if you have a universal set of 1, 2, 3, 4, 5, 6, 7, 8, okay, then what is set A complement? Everything in the universal set that's not in set A. What would it be? 1, 5, 6, 7, 8. Okay, anyway, if you get stuck, try to look at the notes and then it might all be there. And there's several properties like this, you know. What is A union B complement? A complement intersect B complement. Oh, you can distribute the complement, but you gotta change the union to intersection. Hey, that's like logic. Those of you in pre-calculus, hey, that's like logic. It is logic. So all the things we learned in logic, you can apply to sets actually. Okay, let's move on. Okay, so probably the hardest event for you guys is going to be geometry. Okay, now there's certain things you got to know. Okay, let's review. You guys know, like, if you have two parallel lines and you cut it with the third line, then the alternate inferior angles are equal. What about if two parallel lines that cut with the third line, then the corresponding angles are equal? Okay, those are easy, right? If two lines intersect, then these vertical angles are equal. Okay, yeah. Okay, but what about this? If you have a triangle, what is this angle here called? It's called an exterior angle there. Exterior angle is equal to the sum of the two remote interior angles. This one comes up a lot, so it saves you some time. So if this is 30 and this one is 38, then this is 68. That comes up quite a bit. Okay, and another thing that helps a lot is anytime you see a triangle and they tell you these two sides are equal, then these two angles are equal. This is probably the most important thing you're going to see. So let's look at your tryout. Now this was an easy problem. I think they made the tryouts a little too easy this time. Next time it's going to be a little tougher. Okay, so A, B, C, D, E. AB equals BC equals AC equal AD equals CE. These 5 segments are equal. And this is a right angle here. Compute the measurement of angle BCD minus CDE. Okay, well first of all, if all 3 sides are equal, isn't this an equilateral triangle? So wouldn't it be 60, 60, 60? And if this is a 90-degree angle, this would be 30 here, right? Okay, now look. You have a triangle right here. These two sides are equal, so these two angles are equal, so that's 30, this is 30. Okay, what else do we know? Oh, right there, these two sides are equal. So that means these two angles are equal. But then they have to add up to 180, so what? So this would be 75, 75. And if that's 75, that's gotta be 105. And if that's 30 and 105, 135, then this is 45 right here. And then once you label all the angles, this problem is just really easy, right? But what happens if, okay, like when you do the harder problems, what happens if, like, okay, let me take away one piece of information, like, oh, what about that? Okay, what if I take away BC is congruent to the other ones? Now what do you do? So this is what you do. Okay, These two sides are equal. That means these two angles are equal, but I don't know what they are, so call them something. What do you want to call it? Wrong! A. No, it doesn't matter what letter you use. Okay, now, once you label that A and A, what's this angle over here, Larry? 180 minus 2A. Oh, but if that's 180 minus 2A, how do I label this one? Because it's got to add up to 90, so what? 2A minus 90, because the 2A's got to cancel out, and 180 minus 90 is 90. Oh, but if this one is that, and these two angles are equal, how do I label these two? These two got to be equal, but this, and this got to add up to 180. So wouldn't it be, first of all, minus A, because to cancel out the 2A, and then we got to add up, so wouldn't it be 135 minus A and 135 minus A? You guys know what I'm doing, because they've got to add up to 180. Anyway, okay, if you have a hard time, just do this then. Call it B. And then look, 2B plus 2A minus 90 got to equal 180. So 2B is equal to 270 minus 2A, divide by 2, B equals 135 minus A. See, I told you. This is how you do the tougher problems. And then look, these two sides are equal, so if this is 2A minus 90, this is 2A minus 90. Oh, but if this is the 135 minus A, then this one over here is going to be what? 45 plus A. Oh, and if this is A, and this is 135 minus A, what's this angle over here going to be? Because these three got to add up to 180. 45. And then how do you, oh, so we could have actually done this problem, because look. And then now you write an equation. Once you label everything, then you just go, this plus this equal 180. So let's try it for funsies. 45 plus 45 plus A plus 2A minus 90 equal 180. So 3A equal what? Yeah, 180. A equals 60. Yeah, but then we didn't even know it was equilateral. But see, so we could have actually deleted that information and we'll still call it 80 equals 60. Wow. See, captains are demoted for that one then. Anyway, this is the typical problem when you do Event 2. This is how you do it. Label all the angles. The harder ones, like I said, are the ones with variables. And then try to write an equation like, oh, this plus this equals 180. Okay, and then the last thing, well, second to the last thing. Now, I know you guys are not in Algebra 2 yet, but you guys need to know sums and differences of cubes, because it comes up everywhere. Okay, let's see if we know it. X cubed plus y cubed. What is that equal to? Do we know this? This is in the notes, I believe, right? X plus y times x squared minus xy plus y squared. What about difference of cubes? X cubed minus y cubed equal x minus y times x squared plus xy plus y squared. Okay, so even though you ninth graders, it still pays to know this, okay? Because Event 6, you're going to need that. And work problems. Look at problem number 1 now. Yeah, you freshmen are not in Event 1, but I want everybody to know how to set up these problems now. A lot of you just figured it out. That's because this is an easy problem. Because it says, look, scurvy can swab the whole deck in 2 hours. What if if I were writing the problem, I would write, scurvy can swab the whole deck in X hours. Then you wouldn't just be able to figure it out, right? You know what I'm talking about? How many of you actually wrote an equation with variables in it? The rest of you just figured it out? Okay, so I'm going to show you how to do work problems, okay? Which is in the notes. Did anybody look at the notes? I had an example in there. Yeah. Okay, so let's say A, Alfredo can paint a room in 2 hours. What is his rate then? What would his rate be? 1/2. He can do half a room per hour. You guys get it? Bernardo can paint a room in 3 hours. What would his rate be? 1/3. Because he can do 1/3 of a room per hour. Does that make sense? Carlos can paint a room in 5 hours. No, let's say X hours. So what is his rate? Why am I doing this problem when I want to show you that one? Okay, you guys understand how that works? And then rate times time equals work done. Okay, yeah, let's just do the problem over here. Okay, so we got scurvy, and scabies, and halitosis. Okay, scurvy can swab the whole deck in 2 hours. What's his rate? 1/2. Scabies can swab half the deck in 90 minutes, so he can do the whole deck in 3 hours. So his rate is? Okay, good. Halitosis, what does it say? Can swab 2/3 of the deck in 1 hour. So that means his rate is 2/3. Oh, right there, 2/3 per hour. Okay, now, see, this is easy because these are all numbers. You know what I'm talking about? Once you put variables in there, then it's very difficult to just figure it out. Okay, now, what does it say? Scurvy and scabies work half an hour. So if these two guys work together, what is their total rate going to be? Isn't it going to be 1/2 plus 1/3? That's their total rate. And how long did they work?
An hour.
They worked for half an hour. So rate times time equals work done. That's how much work they did, okay? Then scabies gets kicked overboard and he gets replaced with halitosis. Okay? Okay, so if those two guys work together, these two guys, what is their total rate? 1/2 plus 2/3. And how long did they work? We don't know, so we call that X. But if I add the work done here plus the work done there, what should the total result be? 1. One job. There's one job to be done. Okay? That's how you set up work problems, just like that. You guys get it? So from this day forward, anytime you get a work problem, you don't just figure it out, you write an equation. Because the harder ones, you're not going to be able to figure out. Probably when you're in intermediate school, the kind you get are the kind you figure out. But now you're going to write equations. Okay? Okay, any questions on what needs to be done? Okay? So just make sure your first order of business is to finish the geometry worksheets. Yeah? So if you have any questions, come see me now. Or you can ask your friends, whatever. Just make sure you get it done. Yeah? Okay, that's it. And then we'll see you on. So if you forget anything that happened here, I'm going to put this up on the website. So do you guys understand what sample problems are? The difference between sample problems and actual test problems? Did you guys go on the website? Click on like event 2. So at the very beginning, they have sample problems. Then they have the actual test from the last 20 years, and then they got the answers on the bottom. I think so. Every event on Meet is set up like that. Oh, and another thing, on the marathon, it's on the calendar, but varsity people bring food, JV people bring drinks. 24 units, so like 24 bottles of water, 24 cans of juice, whatever you like to drink. And you don't have to bring a cooler, we have a Matthew cooler there. So you just bring the drinks in the morning, or if you want to bring it early, you can, and then I'll put ice on it, so when we work after school, it'll be cold. Okay. So does that help? You're not going to know until you start doing the worksheets, yeah?